Hello everyone, so for today's video we're going to discuss about priority scheduling. Alright, so let's see what is the question and let's see how we can solve it. So here is a problem. Consider the set of processes with arrival time in milliseconds, CPU burst time in milliseconds, and priority 0 is the highest priority, shown below. None of the processes have I/O burst time. The average waiting time in milliseconds of all the processes using preemptive priority scheduling algorithm is blank. Alright, first of all, let's try to understand what this question is trying to ask. So here it says that we are given 5 processes with process ID P1 to P5 and their arrival time given in milliseconds, which is shown here. And then burst time also given in milliseconds, which is shown here. And then we are having the priority of each of these processes shown in this column. And then 0 is the highest priority. So if you see 0, this is the highest priority, and the next highest priority will be 1, then 2, and 3, and 4. So we're given this much of information, and then also it is said that none of the processors have I/O burst time. So what do you mean by this? That here we are given the burst time. So burst time is the time that a process spends execution in the CPU, and I/O burst time is the time that the process spends for input-output operations. So here it says that it does not have any I/O burst time, so we just need to consider only the CPU burst time, which are given here. Alright, so given these informations, we are to calculate the average waiting time in milliseconds of all the processes using preemptive priority scheduling algorithm. So we need to assume that the CPU is following a preemptive priority scheduling algorithm, and if it is following a preemptive priority scheduling algorithm, then that will be the average waiting time for this set of 5 processes. So that is what we are asked, and we are given 4 options: A 30, B 31, C 32, and D 33. So these options are very similar to each other. So if you are trying to guess, then you may have the hard luck. So let us see how we can solve this in the correct way and find out what is the answer. So coming the solution, I have just copied down that same table here, and we are going to first form the Gantt chart for this. So the most important thing in solving this kind of problem related to scheduling is forming the Gantt chart. So if you are able to form the Gantt chart correctly, you can easily solve any problems related to this. So first of all, let's see how we can form the Gantt chart, and keep in mind that this is a priority preemptive scheduling. It is preemptive. So when a process of higher priority arrives, then if the priority of the process is higher than that of the currently executing process, then the currently executing process can be preempted, or the CPU can be taken away from it. So keep this in mind. Alright, so let's see how the Gantt chart for this can be formed. So here is the Gantt chart for this set of processes. If they are following a preemptive priority scheduling, so if we look at this table, let's see which is the first process to arrive. So we see that P1 arrives at time 0, so P1 is the first process to arrive. And what is the priority of P1? It is 2. Since P1 is the first process to arrive, and since there were no other processes at that time, so P1 will be the first one to get the CPU in this case. So P1 gets the CPU and begin its execution. And how long will P1 execute? It has to execute for 11 milliseconds. That is the burst time of P1. So did P1 execute for 11 milliseconds? No. Let's see why. That is because the next arrival time that we have is 2. At the milliseconds P4 has arrived. So P4 arrives at 2 milliseconds, and let's see what is the priority of P4. The priority of P4 is 1. So is the priority of P4 higher than that of the currently executing process, which was P1? Let's see, P1 priority was 2 and P4 priority is 1. So always keep in mind that the lesser the value, the higher the priority. So here P4 is having the lesser value, which is 1. That means the priority of P4 is higher than that of P1. So what will happen? P1 will be preemptive and P4 will get the CPU. So the CPU is taken away from P1 and P4 gets the CPU at 2 milliseconds. So how long did P1 execute? P1 executed for 2 milliseconds and the burst time of P1 was 11 milliseconds. So if we subtract 2 from 11, P1 has a remaining of 9 milliseconds to execute. So P1 will still have to execute for 9 milliseconds. The next time we'll get the CPU. So right now P4 got the CPU and it's beginning its execution. So let's see before continues its execution and let's see what happens. So what is the next arrival time that we have after P4? It is P2, which arrives at 5 milliseconds. So P2 arrives at 5 milliseconds. Let's check the priority of P2. It is 0. So 0 is the highest priority that we have. So the priority of P2 is higher than that of before, which was currently executing. So what will happen? P4 will also be preemptive and P2 will get the CPU. So the CPU is taken away from P4 and P2 gets the CPU for its execution. So how long did P4 execute before executed from P2? From 2 to 5 milliseconds. So that means it completed 3 milliseconds of its execution. And what is the total burst time of P4? Is actually 10 milliseconds. So from the 10 milliseconds, if we subtract this 3 milliseconds, which was already executed, we have a remaining of 7 milliseconds for P4. So P4 will again have to execute for 7 milliseconds. Later engine gets the CPU. Alright, so let's see. So P2 now get the CPU and it's continuing its execution. Now if you look at this table after P2, let's see what are the other processes that arrived. So after P2, which arrived at 5 milliseconds, the next processes to arrive is P5, which arrived at 9 milliseconds, and after that even P3 arrives at the 12 milliseconds. So this 9 and this 12 all fall under this to 5 to 33. That means during the execution time of P2, these two processes P5 and P3 arrived but didn't get the CPU. Now why they did not get the CPU? Because the priority of P5 is actually 4, which is less than that of P2, and then the priority of P3 is also 3, which is also less than that of P2. So P2, as I told you, has 0 priority, which means the higher priority, so no processes will preemptive. P2 because it is of the highest priority. So P2 will actually execute for its total burst time, 28 milliseconds. So from the 5th milliseconds, when P2 got the CPU up to or 33 milliseconds, 5 plus 28, it is 33. So up to the 33 milliseconds, P2 uses the CPU for its executions. Alright, now at 33 milliseconds, P2 will release the CPU, and let's see what are the next processes that we have and who is going to get the CPU. Next, now if we look here, let's just cross out P2 because P2 has completed its execution. Now in the remaining processes, which is the processes having the highest priority? So we have P1 with a burst time of 9, P3 with a burst time of 2, and P4 with a burst time of 7, and P5 with a burst time of 16. Now the arrival times doesn't matter because they have all arrived and they are all waiting in the ready queue. So among these 4 processes that are present in the ready queue, the process with the highest priority will be the next to get the CPU. So let's see here we have P1 with a priority of 2, then P3 with a priority of 3, P4 with a priority of 1, and P5 with priority of 4. So which is the highest priority? We have 2, 3, 4. So 1 is the highest priority that we have among these 4. So P4 will be the one to get the CPU. Now, so P4 gets the CPU and it is continuing its execution. So how long will P4 execute? P4 has to execute for 7 milliseconds because it has already executed 3 milliseconds before and 7 was the remaining time it has. So it will execute for 7 milliseconds. So P4 continued to execution from 33 plus 7, which is up to the 40 milliseconds. Now, before also completes its execution, so let's just cross it out now in the remaining process that we have, which is P1, P3, and P5. Who is having the highest priority? P1 is 2, then P3 is 3, and P5 is 4. So among 2, 3, and 4, the highest priority is P1, which is 2. So P1 will be the next one to get the CPU. So P1 gets the CPU at the 40 milliseconds. When P4 release the CPU, and how long will P1 execute? P1 will execute for 9 milliseconds, so 40 plus 9 is 49. So up to the 49 millisecond, P1 executes, and after that, let's see what are the processes that we have now. So P1 also finishes, then the only remaining 2 processes that we have are P3 and P5. So among P3 and P5, which is the highest priority? P3 is priority is 3 and P5 priority is 4. So the higher priority is that of P3, which is 3. So P3 will now get the CPU and it will execute for how long? P3 will execute only for 2 milliseconds. That is the burst time of P3. So from 49 up to 51, P3 execute and completes its execution. Now, the only remaining processes is P5. So P5 will finally gets the CPU and P3 releases it at the 51 milliseconds. So P5 gets the CPU and how long will it execute? It will execute for 16 milliseconds. So P5 executes from 51 plus 16, that is up to 67 milliseconds. So P5 executes up to the 65 milliseconds, and at this point, all the processors have completed their execution. So this is how we form the Gantt chart for a set of processes that follow up preemptive priority scheduling. So we saw that whenever a process of higher priority arrives, if the executing process is of the lower priority than the one that has arrived, then the process having the higher priority is given the CPU, and the process that was executing currently was preemptive. So there was a simple rule that we have followed, and keeping that in mind, we have formed this Gantt chart. Now, if we have formed this Gantt chart, now the rest of the things becomes very easy. Now we have to calculate the waiting time, so that is what our question. So how do we calculate the waiting time for a set of processes that we have? So here is how we do it. Waiting time equals total waiting time minus number of milliseconds process executed minus arrival time. So using this formula, let's calculate the waiting time for processes P1 to P5 and then see the average waiting time. So the waiting time for process P1 will be the total waiting time of P1. What is the total waiting time for P1? So to see the total waiting time, what do you have to do? Is you have to look at the Gantt chart and see where did P1 occur the latest. So P1 occurred latest over here. This was the last occurrence of P1. So what is the waiting time for P1 during its last occurrence? It was 40. It caught the CPU at the 410 milliseconds. So that is a total waiting time of a particular process. So for P1, it is 40 minus the number of milliseconds the process executed before. So before executing here, did P1 execute any time before? And if yes, how long did it execute? So if you see in this Gantt chart, P1 executed even here. So and how long did it execute for 2 milliseconds? So minus 2 and minus the arrival time. For that, you have to look at this table. So the arrival time of P1 was 0. So we have 40 minus 2 minus 0, which give us 38 milliseconds. So that is the waiting time for P1. So similarly, for P2, the waiting time is the total waiting time of P2. So where is P2? The last occurrence of P2 is here. P2 actually occurred only one time. So P2 total waiting time 5. 5 milliseconds minus a number of milliseconds it executed before. So we see that P2 did not execute before. So it is 0, and then the arrival time of P2, that is the arrival time of P2, it is 5. So 5 minus 0 minus 5, which is 0 milliseconds. Next is the waiting time for P3. So 49 minus 0 minus 12 is equal to 37 milliseconds. Next is the waiting time for P4. So 33 minus 2 minus 2 is equal to 28 milliseconds. Last is the waiting time for P5. So 51 minus 0 minus 9 is equal to 42 milliseconds. So we have got the waiting time for this set of 5 processes. Now, calculation of the average waiting time is very easy. To the average waiting time is 38 plus 0 plus 37 plus 28 plus 42 divided by the number of processes, which is 5. So that gives us 145 divided by 5, which is 29 milliseconds. So this is the answer to our question. So let's see if we have this 29 milliseconds in our option. If we see our question, we see that option A is 29 milliseconds. So the answer to the question is option A, which is 29 milliseconds that we have just calculated. So that is how you calculate the average waiting time for a preemptive priority scheduling algorithm. And always keep in mind that whenever you are solving this kind of problem, the most important thing is to form the Gantt chart. So quickly form a Gantt chart correctly, and after that it becomes very easy to solve the problem. So I hope this was clear to you. Thank you for watching.